Hi. Many ecologists are studying how different aspects of vegetation vary with land management practices. We know that the models hold for the points we visited, but we need to know if they hold for the rest of the region. Using satellite imagery and machine learning, we can upscale the information collected to a regional scale and study how the vegetation varies across space and time. And that's what we are doing at the project SEBAS, Sensing Biodiversity Across Scales. My name is Javier Muro, and I welcome you to my presentation on modeling vegetation in grasslands with deep learning and Sentinel-2. We are studying the interactions between land use, ecosystem services, and biodiversity in grasslands across scales and across environmental gradients. For that, we are using UAVs, satellite imagery, and deep learning to model several vegetation attributes, such as vegetation height, biomass, or species richness. Although there are several studies that already model vegetation attributes with remote sensing, these are often calibrated using a very narrow range of environmental conditions. This makes models not replicable and not generalizable to a regional scale. The advantage of our study is that we are covering a very broad range of environmental conditions. We are conducting our experiments in the biodiversity exploratories. They are a set of 150 well-monitored grassland plots across Germany, and they cover a very broad range of environmental conditions: climatic gradients, altitudinal gradients, soil types, and management practices. Some of these plots, for example, are extensively grazed, and others intensively grazed and very frequently mown, and the range of fertilization inputs also vary. Some are very species rich, and others are very poor in species and low biodiversity indices. In summary, this is a very complete scheme. To assess the performance of our models, we perform several validations: spatial cross-validation, temporal cross-validation, and k-fold. And we obtain quite a good fit for biomass, vegetation height, and species richness predictions, as you can see in these charts. Once validated, the models have been used to make predictions, for example, across time. This chart shows the amount of biomass for two example plots: extensive management and intensive management. Knowing the amount of above-ground biomass across the year has very important implications for not only for productivity, but also for ecology studies, since it provides information on the availability of food and habitat for several organisms across the year. The predictions can also be made across space, revealing which grasslands are most or least productive. We can see in these examples that the patterns in productivity and biomass are inversely correlated to the species richness. The areas that score high in biomass here, they score very low in species richness. Our analyses have allowed us to calculate the species richness around our experimental plots as well. This has important implications because it gives information about the rates of spillovers of seeds and pollinators into our experimental plots. Our analyses have also allowed us to see other grasslands that are very rich in species that are further from our experimental plots. Having this information at regional level is very important for management purposes. Through our studies, we have learned several lessons. First of all, the machine learning algorithms we tested, we saw that the neural networks and the Sentinel-2 predictors generalize better across the three exploratories. The satellite data from March and October were key to predict the species richness. This means that the model is learning useful information from the greening and browning phases of the vegetation. Currently, we are working on data augmentation techniques using UAVs to improve our results. We are mapping the biomass at UAV scale and then using that as an input to calibrate our satellite-based models. This brings us to the end of my presentation. If you want to know more about what we are doing, do not hesitate to contact me or my PIs, Professor Aniel Insteta or Professor Ornella Dubovic. In the name of the rest of the SEBAS team, I thank you for your attention.